Okay, dual wave particle nature of light. Particle portion. Light is caused by particles. Those particles we know are electrons being excited due to, I'm going to say, the addition of energy. So think here, and I would expect you, I mean, I'm being brief. If I ask you a short answer about this, you're going to have to explain it a little bit more in depth. Think here, ground state, excited state, and then back, and what happens. Then I guess we could look at the wave portion. We know light is caused by the electron. But has wave-like properties, which I think we talked about all of those. And travels in waves. So think of this as light energy caused by electrons, travels in waves. So that's kind of an abbreviated version of dual wave particle nature of light. And that seems to be one of the things that people have the most trouble. It's pretty simple, but people have trouble explaining that. So that's one thing I wanted to hit again. And then the other thing I wanted to show you goes along with electron configuration notation and one of the weird things on the periodic table. So get your periodic table out that you put the blocks on that we did last Friday.
Why? You can't be doing that.
This is probably a silly question, but do you need to memorize like the
Yes, you'll have to know that. Okay, so what I want to talk about is called, excuse me, anomalous electron configurations. So we have certain elements, and we'll talk about a couple of them. Certain elements that, if I were to give you a table that had all of the electron configurations for every element on it, there would be some that if you mapped it, you would say they're not right. Because there are certain elements that appear to violate, I'm going to say, the rules of electron configuration notation. Now I want you to look on your periodic table and I want you to find chromium. I need to grab a periodic table. So find chromium on your periodic table. Figure out how many electrons it has. And then just wait till everybody gets there. How many electrons does chromium have, Rachel? 24 electrons. Now, I want you to, and I don't care if you write out all the arrows or if you just do shorthand, if you're good enough to do that. I want you to write out what the orbital shorthand would be for chromium. If you have to do the arrows first, that's fine. Take a minute and do it. And do me a favor, when you've got it, stand up. That way I know we're all in the same place. Okay. Kayla, read me your mapped out one, your shorthand. 3D4, is that what you said? 4S2. That's supposed to be a 6. I got a little messy. If yours looks like that, sit down. Yay you. You got it right. That's what you would think it mapped like. What it actually is this, and I want you to write this down. 1S2, 2S2, 2P6, 3S2, 3P6, 3D5, 4S1. I'm going to actually move this up a little bit. Okay, do you see the difference in the two? And this actually happens if you look at your order of filling. Where is the first place that my energy levels start to get close together and may possibly overlap? See if you can figure that out from your little order of filling thing. Look at your card and figure it out. Max, are you raising your hand?
Yes.
What do you think?
Because 3D and 4S are kind of...
3D and 4S is the first place where we start to see that, oh wait, 4S fills before 3D, right? So we start to see the fact that the 3D part of the third energy level and the 4S part of the fourth energy level have very similar energies. So this happens because I'm going to say 3D or whatever D, this could be any energy level number if there's a D. And in this case, the 4S, or any S energy level. It could be 5S, it could be 6S and 5D, it doesn't matter. They're very close in energy. And so what happens is the atom, I'm just going to say, is happier when each sublevel in D has one electron, rather than having that one empty sublevel. So that D gets the electron, and then the 4S only gets the one leftover one. We see this mostly in the transitions, and we'll talk about where. Now I want you to find copper. Does that make sense, Annika?
Yeah.
Okay. You have a frowny face.
I just can't see it.
Oh, Where are your glasses? I've seen you wear them like once. All right, find copper. And I want you to map copper real quick. And you can just do your orbital shorthand if you want to. When you've got it, stand up.
Yeah.
Josh knows it.
Well, you ought to be able to predict what's going to happen at this point.
Josh predicted it.
Good job, Josh.
I know the same thing.
You don't matter as much though.
Did you do the actual one?
No.
No? So what'd you predict it to be, Rachel? You said no. Tell me, you just did the mapped one. Then did you predict what the actual would be? Okay, read me your mapped one, Rachel.
1s2, 2s2, 2p6, 3s2, 3p6, 3d9, 4s2.
3D what? 9? 4S2. Now, if I look at this, here we are again. I picked these because they were quicker for you to map. I could have picked a big long one, but I was nice and didn't. Look at what happens here. I have 9 here and 2 here. What's going to make this D happier? To be full. So the actual looks like this. 1S2, 2S2, 2P6, 3S2, 3P6, 3D10, 4S1. This same thing would happen right here if I were dealing with 4 and 5, 5 and 6, 6 and 7. If you look at your periodic table, that group 6, or it's really 1, 2, yeah, it's labeled group 6 on your periodic table, and group 11, that happens in every element in those groups. You might want to circle 6 and 11 just so you are aware of those anomalies. What? Yeah, group 6 and group 11. Like if I would have made you do silver or gold or molybdenum or tungsten, you would see the same things happening. Or if I were to give them to you, you would see the same things happening. So be aware that that happens. Be sure that you can like explain why that happens. And really, that is the end of the unit. Yes, Avery.
So in the transition metals, it's only 6 and 11 that does that?
Those are the most common. There are a couple others I'm not going to ask you about them, but in those two groups, that is what happens. And there are also a couple in the F block that happens to, but I'm going to focus because it's repetitive there. I'm going to focus on those two groups. But understand there are some anomalies throughout the periodic table where weird things like that happen. Okay? All right, now grab that review I had you pick up. I need to find mine because I need to tell you what you have to do. And I don't know where I put it.
Read it a while.
Shoot.
Like,
Oh, no, that's not it. Oh my goodness. Here it is. So notice, I had a little issues with the copy machine. There's one page missing. I'll give it to you tomorrow. My learning goals are on the first page. On the back of the first page, you can get rid of number 29. Because I have saved that for the next part of the unit. And then if you look at the back, Maybe I need to look at one of them. Somewhere, I don't know, maybe I didn't staple it on mine. At the very back, the very last page, I think you have some added learning goals, because they didn't come through, so I had to go back and reprint them. Now, let's go through this other stuff, because there are some things you are not gonna do.
Hopefully describing what each person did on the back of the first.
That's not it. All right, I'm going to the multiple choice.
I have a question about F under the back page, or the back of the first page.
D broccoli.
DeBroglie?
I don't remember.
Okay. I'll have to go back and look and see if we
We
have
know.
anything on him.
I don't.
He might be in your, just in your reading, your chapter.
Oh, I didn't do that.
Oh, well, you'll have to look. All right, let's go. I do not want you to do number 10, 13, 16. Oh, and 7.
Good.
7,
Question.
7, 10, 13, 16.
Wait, what?
These are the ones you don't do.
The ones I.
Do not do. 7, 10, 13, 16.
Do this.
I'm going to slap you right here in front of everyone. All right, then you don't need to do number 17, number 31, or 32. All right, then on the back, I'm going to tell you what to do because there are several we skip. 38, 39, 40. These are the ones you do. 42, 44.
They're circled.
Yeah, but I'm gonna add some. And then you don't do anything else until 57. So like I have 56 and 51 circled, you don't do those. Then I'm going to the next page. You do 58, 59, 60, and then everything else, don't do 61, and then you do all the rest. So you're not doing 61. You're doing 62 through 67 on that page. And then on the back of the page, 68, 69, yeah, 71's fine, 74, 75, 77, try it, you should be able to figure it out, we just briefly talked about that. 79, 80, 81, 82, 83. And like I said, there's one missing page, I will print that off and give it to you tomorrow morning.
Thank
You will have today and tomorrow to work. We will, what's today? Okay, it's really Monday. Last week was so messed up.
you.
Yeah, today, tomorrow work, so we'll test Wednesday, Thursday. And one day will be probably the math and the configurating, and then the other day will be multiple choice short answer. Okay? Wake up! All right, let's go. Let me know if you need help. And I'm going to look up. So you guys, the de Broglie and Heisenberg, those are like 224 through 226. Those were things that they were part of your reading a long time ago. Clearly, you didn't do that. Or you have no memory of it. Remember that green sheet you have for this unit as well.
Miss Beal?
Yeah.
We didn't read that.
We stopped at 6.3.
Yeah, it's not on there, I know, but I'm just telling you
You
to.
just gave a check for not reading it.
No.
Yeah.
Listen, I separated those two things though. I said you also have that green sheet.
I know, but we stopped.
We stopped at, like-
6.4 instead of 6.
Well, was that the day Mrs. Spilazewski was here?
I think so.
Yeah, that was in part of her instruction, so that's on me and her, I guess. So read it. It's very simple. Her and I. Me and her and I, all of us.
She should have just known we had to read the next one.
I know. Ah. Hey Carter, I hope you feel better soon.